Speaking of tips and ways that people can be getting ahead more quickly, you mentioned to me prior to us recording that you've been loving using AI coding assistants. And tools like Cursor, Claude Code, Codex, how has your workflow changed as a result of these kinds of tools? How does that impact, in particular, AI systems performance, optimization? And what do our listeners need to know about where this is going?
For sure. I tweeted about this a couple weeks ago. If you're manually writing code in this year 2026, you are way behind. And I would not have said that if I didn't spend all of last year watching this sort of evolution, because I started off um, in my sort of legacy ways, right, where I was writing every line of code. And I vowed for 2026 to only use these coding assistants and to see how far I could get. Now, I've done a couple of projects for some friends and for some portfolio companies, and just to make sure that So the short of it is, you can fire off about 10 to 15 different things, like different aspects of either features that you're trying to build or bugs that you're trying to find. I'm personally using these tools right now to do a lot of optimizations and to look at different aspects. And so I'll say, take a look at the like occupancy, percentage for this particular kernel that I'm trying to optimize. At the same time, I'm having another GPU that has the same code that's analyzing a different part of it. And so, think of a four GPU system, and you can run separate experiments, each one running on a different GPU, or even four separate GPUs, like separate nodes that have their own memory and stuff. But yeah, my personal workflow, I'm going to be a little controversial and say I prefer Codex. Yeah, I prefer the OpenAI. One thing, and again, very, very workload specific, I would say. I think if I was doing UI stuff, I would probably, maybe prefer Claude right now. Claude's great with the UI. It's kind of my little dirty secret that I use Codex. And so while all the other developers are flooding the Anthropic GPUs and the inference stacks, I've got kind of my little group of people that just use Codex, and I still have really good performance until people realize that Codex is actually better for other stuff. But for right now, I'm enjoying good performance and fair amount of token. But the one thing I would recommend for AI systems performance would be on the machine. Don't try to do this stuff on your MacBook and hope that it works, or even on like a personal like NVIDIA GPU, like an RTX, yeah, I don't know, 50. Like, I've literally never used any of the personal GPUs, because to me, the profile is so different, the hardware is so different, the memory bandwidth completely different. So if you are working on an AI project and you are ultimately going to deploy on a Blackwell or on a Hopper, you have to be on that machine during development. Don't try to take any shortcuts. I recently tried the DGX Spark, which is the little mini one that got a lot of buzz, the end of last year. There's so many things disabled on that none of my benchmarking was even working, because it's just completely missing a lot of core hardware components, and then software components on top. The driver isn't the same. It's a lot of different things.
Nice. Really appreciate your insights on what you're doing with the coding assistants today. When you're working on those, Chris, do you still review all of the code before it goes to production?
I did. I was once, yeah, I was once like you, or once like the question that you're asking. In
Yeah.
fact, I was just working I was just working with someone this weekend, trying to get them a little bit up to speed. It's a good friend of mine, and I'm like, look, you're doing things like you're going to be outdated within by St. Patty's Day. Was the joke specifically. And I was watching their workflow, and these assistants, they like to write little snippets of Python code, or any or Bash scripts to get stuff done. and this person was literally reading every single line of the bash script. Like it's happening during the thinking process, and they would go up and they would expand it and they would be looking and they try to find the script on disk. And I'm like, dude, you have to let go, you know? So um, the short answer is I did, and it's exhausting. And I've learned to step back and, there's like temporary scripts that these things write to write the final code. And you could do that and you could be very disciplined and, like review all the lines of code. You could write tests. You can have the like LLM actually write the tests as well too. I've actually even sort of let go of unit tests, and this is very controversial for all of my test-driven friends and folks that are listening. I focus on the evals, so I clearly set up and provide examples that I know are correct. Those are sort of the like collaboration set, and then I use the LLM to actually judge the quality. I have it constantly running. So I've got evals that are always running in the background in a separate tab while I'm, building the software. So short answer is no, I stopped doing that. And it really slows things down, and it's hard for people to do. But I'm shipping code a lot faster. You know, with kernel optimization, you have to be very careful. These models want to hack the reward, or it's called reward hacking, and just get the fastest thing possible. And if that means zeroing out everything to make the computations a lot faster, it's going to do it. And so one thing I spent a lot of time on with my GitHub repo is these like correctness checks and correctness verifications. And these pop up, yeah, every single month. Someone like release some small little startup releases something that they have achieved 50x speed up, and the first thing I do is take that code and I put it into my harness, and boom, I see that they're not using CUDA streams properly, or that they have that it's not their fault. It's just that they've given the LLM too much freedom. And so we have to get better about what it means to review. And I don't think even going through all the code that you would be able to catch these things, because I assume that they went through and looked at the code, but not unless you're actually running the code on the machine and you've got all of the profiling set up where it can show you how many streams are being used and all the different aspects. If you don't have correctness checks, if that's in the form of evals for your sort of end user application, or performance metrics and like real correctness checks within your performance harness, then you're not doing it the right way.